we already learned what is an arithmetic expression, right? If sum of first n natural numbers is s1 and the squares of first n natural numbers is s2 and sum of the cubes of the first n natural numbers is s3, then prove that 9s2 square is equals to s3 times 1 plus 8 s1. So as we know that what is s1? s1 is equal to sum of the first n natural numbers, that is 1 plus 2 plus 3 plus 10 as equals to, which is n into n plus 1 by 2. And s2, you know that s2 equals to sum of the squares of the first n natural numbers, which is 1 square plus 2 square plus 3 square and so on, equals to n into n plus 1 by 2, 2n plus 1 by 6, right? Then I know that f3, what is f3? Sum of the cubes of the first n natural numbers, right? Sum of the cubes of the first n natural numbers is given by s3, which is 1 cube plus 2 cube plus 3 cube plus yes, and which is n square times n plus 1 whole square by 4. If it is so, then we need to prove that 9s2 square equals to s3 into 1 plus 8 s2. Okay, we equate the left hand side. What is the left hand side? It is 9s2 square. It is enough to prove that 9s2 square equals to s3 into 1 plus 8 s2. Alright? So 9. What is s2 here? What is s2? n into n plus 1 into 2n plus 1 by 6. So in place of s2, I am going to write n into n plus 1 into 2n plus 1 by 6 and this square. What is that? 9s2 square? No. So what we written 9 and s2, then s2 has the power 2, hence 9 into n plus 1 into 2n plus 1 by 6. And on simplification, we will get that n square n plus 1 whole square 2n plus 1 whole square by 6 square. What is 6 square? 36. 6 square is 36, you know. Right. And 36. So you cancel 9 ones up and 9 fours up. So 9 fours are 36. Alright. And then we left with n square into n plus 1 whole square by 4 into 2n plus 1 whole square. Right? So what is this n square into n plus 1 whole square by 4? Then I written that as 3. As 3 is n square into n plus 1 whole square by 4. Hence, in place of n square into n plus 1 whole square by 4, we can substitute s3, right? s3 into, what is 2n plus 1 whole square? It is nothing but a plus b whole square. If you expand like, a plus b whole square, what do we get? A square plus 2ab plus b square. Based on that, 2n whole square. What is 2n whole square? 4n square, right? 2n whole square is 4n square plus 2 into 2n into 1. What is that? 4n. Right? 2 into 2n into 1. It is nothing but 4n plus 1 square. What is 1 square? 1. Okay, now it is here 3 into 4n square plus 4n plus 1. Okay, if there is any common in these two terms, can we make it any common? Common? 4? Only 4? 10 also. So I can take 4n as common, and then it's nothing but here 3, 4n. What is left with? N. Here I have taken n here, and so n plus 1 plus 1. Okay. If we write like this, you know, S3 into 1 plus, and just checking the terms like 1 plus, this can be written as 4n into 2 into n plus 1, n plus 1, of course. I am multiplying here by 2. If I write by 2, what will happen? S3, so this is S3, 1 plus 4n into 2 into n plus 1 by 2, which if you write like this, you know, S3 into 1 plus 4 into 2, 8, n into n plus 1 by 2. Okay, what is that? Is S3 1 plus n into n plus 1 by 2 is S1. So 8 S1. So we have taken 9s2 square, and we proved that S3 into 1 plus 8s1. Therefore, 9s2 square equals to S3 1 plus 8s1, right? So this is simple. So for which you need to know what is S1, what is S2, what is S. So S1 is nothing but some of the first year natural numbers, which is given by n into n plus 1 by 2, and S2 is some of the squares of the first year natural numbers, which is n into n plus 1 into 2n plus 1 by 6, and S3 some of the cubes of the first year natural numbers, which is n square into n plus 1 whole square by 4, and we have taken this 9s2 square, which is on the left hand side. So I have taken the left hand side as 9s2 square, which means that 9 into s2 we know, n into n plus 1 into 2n plus 1 by 6 square, right? And then which is 9 into n square, n plus 1 whole square, 2n plus 1 whole square by 36. Alright? And if you cancel it, 9 ones, 9 fours, which is 36. And we left with the n square into n plus 1 whole square by 4 into 2n plus 1 whole square. Okay, we know that n square into n plus 1 whole square by 4 equals to S3. And to just expand this term, 2n plus 1 whole square on expanding, we get that 4n square plus 4n plus 1, which is again another expansion of a plus b whole square, which is a square plus 2ab plus b square. Okay, then actually in these two terms there is 4n which is common, so I have taken 4n as a common, and this is n plus 1 plus 1. So just change the order of the terms. So and by changing the order of the terms, the first term will become 1 plus 4n times 2. Here what I am doing is I am multiplying the second term by 2 and dividing same by 2, by which the result is same. If you multiply and divide a term by the same number, then the result might not change. Hence 1 plus 14 times 2 is 8n, n plus 1 by 2, which is in place of n into n plus 1 by 2, substitute s1. Okay, so it is s3 times 1 plus 8s1, which is all h's, and hence the results. That is 9s2 square is equal to s3 into 1 plus 8s1. So if it is given that s1 the sum of the squares of the s1 is sum of first n natural numbers, s2 is the sum of the squares of the first n natural numbers, s3 is sum of the cubes of the first n natural numbers, then so that 9s2 square equals to s3 into 1 plus 8s1, by which we can simply show like this. Have you understood? Okay, let's do it. Take down.